At 450 meters above the valley, Chinese engineers decided to build a glass walkway where almost no conventional structure could stand.
Every panel, every bolt, and every steel connection had to be installed on sheer mountain cliffs before a single visitor could take one step. The project began long before any steel arrived. Survey teams climbed the steep limestone cliffs, carrying Every ridge, crack, and rock layer was mapped. Engineers measured slope stability and identified potential landslide zones. Core drilling machines extracted rock samples from multiple elevations. Laboratories analyzed the strength of the mountain. Every ridge, crack, and rock layer was mapped. Engineers measured slope stability and identified potential landslide zones. Wind data, rainfall records, and seasonal temperature changes were collected. The circular observation platform required
If we adjust the tension here at this intersection, the flow stabilizes. But what about the structural integrity on the lower axis?
It seems the algorithm compensated for that in the last iteration.
If we optimize this segment here, we improve the overall stability. I agree, the structural integrity is key.
What if we reroute the primary load-bearing axis?
Several proposed locations were rejected after geological analysis. Only after months of surveying was the final alignment approved.
How are the stress points managed at this nexus?
We've optimized the load distribution with this tensile grid.
It significantly reduces the material needed.
Building on a mountain created problems that ordinary bridges never face. engineers designed a steel cantilever system anchored directly into the rock.
The construction site had almost no road access. Temporary mountain roads were carved into the hillside.
Cable cranes and winch systems transported steel components upward. Some materials were lifted hundreds of meters by aerial ropeways.
Workers drilled hundreds of deep anchor holes into solid rock. Large rotary drilling rigs operated on specially stabilized platforms. Engineers tested pull-out resistance before approving each anchor. Large rotary drilling rigs operated on specially stabilized platforms. Prefabricated steel members arrived at the mountain in sections. Cable cranes slowly lowered each component into position. Piece by piece, the skeleton of the Skywalk emerged above the valley. The steel frame was complete.
Sometimes. The project demonstrated that building on a cliff demands as much geological engineering as structural engineering.